So in this video, I want to talk about why it is that when using the categorical version of a variable, you would always expect to get performance that's at least as good or better on the training set than if you're using a continuous version of a variable. So here I set up my usual kind of CCR function, and here I'm splitting Titanic up into train and validation. Now, in the Titanic, you have the variable class, and class could be treated either as a continuous variable or as a categorical variable. So the reason is because it's numbered, right? So you have first class, second class, third class. So you could treat those things as numbers, or you could just say, well, it so happens that those are numbers, but really those are just names. So one example where that would clearly be the case is the precept numbers, not like the chronological ones, but like PO1, PO2, PO3, P11, and so on, that are kind of like in the schedule. So technically those are numbered, but you wouldn't say that kind of for maybe anything other than time that really those numbers mean anything. They're just names for the different sections, right? So that you would probably not treat as numerical. Okay, so with class, it's kind of ambiguous because it's like, so class is kind of ordered, and in fact, you could treat it, so there's a special kind of thing that's called an ordinal variable, which is really what class is. But it's kind of like a little bit ambiguous. You can sometimes treat it as categorical, sometimes you should treat it as numerical. So in terms of the implementation, the way it works is if you want to treat P class as numerical, you don't do anything, you just say survive till the P class and so on. And the reason for that is that when you read it in, it's read in as a number, so you can check what the thing was read in as by just looking, saying class, Titanic P class. So class is just like the class of the object. It's not to do with the fact that this is also named P class. And it'll say that it's integer, so if it's an integer or if it's numeric, R will treat it as continuous because it's a number, and if it's something else, then it won't. So here, if we explicitly convert to factor, then R will treat it as categorical. We can also, after we fit the model, see what happens. So if I display fit continuous, I see that the way I'm predicting the probability is logistic of this minus this much times class, so that means that P class is continuous, it's like a number, it's treated as continuous, and so on. But if I display fit categ, because I converted it to factor, you see that the way it will predict is logistic of this, and then if it's class 2, then minus this much, and if it's class 3, then minus this much, and so on. Okay. So what am I claiming? I'm claiming that if you look at the performance of the model, so the correct classification rate in our case, you should expect that the performance would be the same or better on the training set if you're using the categorical version. Okay, so we can check what happened here. So here it's 85% correct, here it's 90% correct, so it is what we predicted. So why is this happening? So to look at that, we need to actually look at how we're predicting. So when I'm predicting using the continuous version, right, I'm predicting, so I'm doing logistic of the intercept, and then I have a variable that's like a male, and I'll multiply it by a male. So if the person is male, then I'll add this much, right? And actually a male is negative, whatever. And then I also have a age times age, and I think we also had, so we also used fair. So I'll also have like a fair times fair. And then if I'm predicting using class as continuous, I'll just say AP class times P class. And that's how I'm going to be predicting. So that's the continuous version of P class. Now on the other hand, so continuous. So on the other hand, let's say that I'm using the categorical version of P class. class. How I'm going to be predicting? So so that's all going to be the same, right? So like a male times a male, and so on. And then for class, it's going to be different. So for class, if it's categorical, then I'm going to leave one category out, and then I'm going to have coefficients for the other ones. So I'll say a P class 2. So let's say that I left first class out, and then that's going to be I P class 2. And I'll add a P class 3, I P class 3. So how is this different? So when I'm predicting here, I'm computing all of that, and then I'm saying AP class times B class, and this could be 1 or 2 or 3. And here I'm saying if it's class 1, just add all of this up. This is just 0. If it's class 2, then you add AP class, because this is now 1 and not 0. If it's class 3, then you add this much, because this is 1, but this is 0. Okay. So for kind of the future, so here this is a 0 and this is a 0, but of course, like R is trying to do as good a job as possible of making this be 1 for passengers who survived and 0 for passengers who did not survive, and same here, and those numbers might not be the same. So what I'll do is I'll denote all of those using primes, just so that so this one actually is not necessary, because here you just have a P class here, you have P class 2, P class 3 here. So just kind of to remember that this one and this one, they are not necessarily equal. Okay. So now what I'm claiming is that if you use the categorical version, you can always do as good a job or better of a job of predicting than if you're using continuous on the training set, right? So why is that? So the reason is that whatever this can do as well. So let me first make this point. So how is it that if this one can predict something, then this one can predict it too? Well, it's just that we can imitate this formula using this formula. So what does this one say? It's saying that for class 1, right? So for P class 1, for first class, we'll predict A0 plus all of that stuff, plus a P class times 1. So this one for class 1, it's going to predict so it's going to predict this much plus all of that, and then this stuff is just going to be 0. So let's say that we want to imitate the predictions that this formula makes using this formula. Well, what we need to do is we need to just say that A0 prime is equal to A0 plus AP class. So this guy. And then everything else should be the same, right? So we would say, so I'll write it here. So like A prime male is equal to a male, and so on. And like AH prime is equal to just AH, and so on. So if I do all of that, so actually there's just one more here, that's the fair. So if I do all of that, and then also I say A0 prime is A0 plus AP class, then for first class, we're going to be predicting exactly the same thing for both the continuous and categorical version. What about second class? So for second class, this one predicts A0 plus AP class times 2, right? So how do we make sure that for second class, this guy is also going to be predicting exactly the same thing as here? Well, we just need to make sure that, so A0 prime is already set, so we just need to make sure that P class 2 is just equal to P class, right? So we'll just say AP class 2 is 2 is equal to AP class And then if we want to also predict the same thing for third class, we'll just make sure that AP class 3 is equal to twice AP class. So why twice? Because here what we'll do is we'll predict A0 plus AP class times 3. So here we also want to predict that, so we'll add A0 prime, that's this stuff, and then we'll also add this part, and we'll get A0 plus 3 times AP class, so we'll get the same thing again. Okay, so what they did here is they said, if the continuous version of the model makes really good predictions, then the categorical version can just do the same thing. Okay, now the categorical version is actually more flexible. So the categorical version can do stuff that the continuous version just cannot. So why is that? Well, one kind of easy way to see it is, like, let's say that AP class is negative. So if P class is higher, so if you're like, if you go from first class to second class to third class, then what happens is the probability goes down. So let's say that AP class is negative. So what can we say? We can say that for any given person, if we switch them from first class to second class, then their probability of survival definitely goes down. And then if you switch them from second class to third class, then the probability is going down again, because this is negative. And then if this is positive, then it's the other way. Then kind of the higher the class, or kind of the higher up in kind of first, second, third you go, the larger your probability of survival. So there is no way that this formula is going to predict that the probability of survival for first class and for third class is low, but for second class it's high. It's just mathematically not possible, because either this guy is positive, in which case the probability of survival goes up as you go first, second, third, or it's negative and then the probability of survival goes down as you go first, second, third. There is no way that the probability of survival is highest for second class according to this formula. But according to this formula, there is no problem. You can do that, right? So you can just say, like, this AP class 2 is very high, but AP class 3 could be negative, right? So that means is that if the data truly is like that, so if the data looks kind of like this, where the probability of survival, so this is like probability of survival. So if it's kind of low for first class, and then it's higher for second class, and then it's lower for third class, then R is going to be able to make those kinds of predictions using the categorical version of the formula, but it just can't make those kinds of predictions using the continuous version of the formula. So in some situations for the training set, you'll definitely get better performance using the categorical version than you would using the continuous version. Now, does that mean that you should always use the categorical version of a variable? No, it does not mean that. So why is that? Well, because it might be that when you're using the categorical version of the variable, you're just overfitting. So how could that happen? So imagine a situation, and that's actually true on the Titanic, that the probability of survival, kind of for the whole set, and that means like for the population, is actually like this, or something like this. So the probability of survival goes down from first class to second class to third class. But in your small training set, it's not like that, possibly because you undersampled, for example, people from second class. So it looks like that's what things are like, because your training set is small and not representative. And if you use the categorical version of the variable, then that is what you're going to be predicting. On the other hand, if you are using the continuous version of the variable, of course, if you have a small underrepresentative training set, that's always bad. But maybe if you don't have very many examples from second class, you'll be able to see the overall trend that the probability of survival in first class is kind of a little bit higher than in third class, and it doesn't matter that there's like a few lucky people who got into the training set in second class and they all survived. We're just looking at the overall trend, because if it's the continuous version of the variable, then R has to decide, like, am I making AP class be negative or am I making it be positive? And if you just have a few data points in second class that don't accord the trend, R is just going to pay the price and say, like, it's worth it to me to pay the price. I'm not going to predict for them correctly, but I'm going to predict for first class and third class correctly. So you could still overfit conceivably, but it's less likely because there is less flexibility when predicting using this formula. So what you would expect on average is that you'll overfit less. So you'll potentially do better on new data if you're using the continuous version. Of course, if truly the correct predictions look like this, then it's just wrong to use the continuous version. Maybe you won't overfit, but you just are not going to be making correct predictions on either the training set or the validation set. If the data truly looks like this, it's not like a small and representative sample, but that's what the data is like. And you're using the continuous version of class to predict. So I didn't actually check, but let's see how the model that we fit here is going to do on the validation set. So for continuous, we get 75% correct, and for categorical, we get 69% correct. So in fact, we do observe overfitting here, right? So we got better performance on the training set for the categorical version, but worse performance on the validation set. So that's likely because of overfitting, something like the picture that you saw here.